you. So as promised, so we only concentrate on the mesh analysis examples for today class. And for next week, we will go for next topic, which is the superposition. Okay, superposition technique, which is another theorem of analysis. Okay, so for the method of analysis, we have only two, which is nodal and mesh. Okay, and for your first test, please be noted that you will be tested on the basic Ohm's law and also the nodal analysis only. Okay, so let's start with, I have posted 3 questions. So we start with this question 3.44, which is I extract from our textbook, Alexander and Sadiko. So the question is, use mesh analysis to obtain I/O. Okay, the current branch that flows through 50 ohms. Okay, so please use mesh analysis. Okay, so first of all, what you need to do is actually to identify the mesh current and your direction of your current, mesh current. Okay, so this one. Okay, so let's identify this one as your I1. So clockwise, all are clockwise. Okay, and then this is I2, and then this is your I3. Okay, so start with the KVL for mesh I1. So I think this one is too thick. Okay, so from here you can see we have negative 400. Okay, negative 400. But and then as you can see here, we have a current source in between this I1 and I2 mesh current. Okay, so what you need to do is actually to have what you call the super mesh. So meaning that the super mesh is from here, including the mesh number 2. Okay, because the current source is shared with I1 and I2. So this is your super mesh. Okay, so we go straight to 100 ohm. So the current that flows into 100 ohm is only I2. Okay, and then 50 ohm. But as you can see, this 50 ohm, there are 2 mesh current that goes through. And since we are concentrating on I2 right now, okay, so meaning that we assume that the current is bigger. I2 is bigger than I3. So we need to write down like this. Okay, so 50 I2 minus I3. And then we go down 50 ohm. Okay, and at this 50 ohm also, as you can see, there are 2 mesh current, which is I1 and I3. Since we are concentrating on I1, which is the super mesh, so we need to write down like this, right? I1 minus I3. So this one is equal to 0. And then if I simplify these equations, okay, rearrange this, I should have 50 I1 and then plus 150 I2 minus 50 I3. Is it? Oh, okay, minus 100. Equals to 400. So this is my first equation from super mesh. So meaning that this is not KVL for mesh 1. Okay, so this one is actually KVL for super mesh. I1 and I2.
Doctor,
Yes.
if we do in anti-clockwise, we can't
Mm-hmm.
get negative 400 but the positive 400 for the voltage 400 V.
Okay. Actually, it doesn't matter if this one is okay. Let's try. It doesn't matter actually. If you will go for counterclockwise or anti-clockwise. And then what are the sign for 50 I1? Is it negative?
Uh,
50 I1 should be, this one should be negative 50 I1, this one should be negative 150 and plus 100 and I3 is equal to negative 100. Should be like that.
what? But why,
Okay.
doctor?
Sorry?
Because if we change to anti-clockwise, we also assume that we enter the positive terminal of 50 ohm resistor, right? But why is negative?
Okay, okay. So I think maybe we can try to do anti-clockwise for all our calculation, okay? So let's try anti-clockwise. I1, I2, and your I3. Okay. So your super node will be sorry, your super node should be like that. We only consisted I1 and I2 because the mesh current is shared with I1 and I2. So mesh current for I1 and I2. So we start here. So meaning that we go positive 400 first. Okay. And then 50 ohm, positive 50, I1 minus I3. Okay. And then plus 50 I2 minus I3 plus 100 I2. So this one is equal to 0. Okay. So this one should be okay. So 50. I got 50 also. Okay. So 50. And then for the I2, so this one is 150 I2. And this one is negative 100 IT. Okay. So this one is become negative, right? So it's actually true what your friend told. Okay. So it's okay. You can just leave it like this. Okay. But actually the final answer will be same. Okay. Let's try. So KVL for mesh current I1 and I2. So the first equation like this. And then KVL for mesh I1 and I2. Okay. So you should be 50. So right now we are concentrating on I3 mesh current here. So 50 I3 minus I1. Okay. So look at the difference. Okay. So right now we are concentrating on the mesh current I3. So I3 will be, we assume I3 is larger than I1. So that's why we write like this. Okay. Plus 50 volt plus 100 I3. Okay. And then plus another one 50 I3 minus I2. This one is become 0. So if I rearrange this, so I will obtain negative 50 I1 Negative
Doctor,
50 I2.
Doctor, we can get I2 easily because we have current source there. It will be
Okay,
negative
the
4.
current source here.
It will be negative 4 because opposite direction.
No, we cannot directly get the value like that because right now, as you can see, the current source here, 4 amperes, is shared by I2 and I1. So we cannot say that I2 is equals to 4. Is that what you mean?
Oh, Doctor, so, forgot. I understood
Yeah,
now.
yeah, because this current source is shared by two mesh currents, so we cannot simply take I2 is equal to 4 or I2 is equal to negative 4, unless if the current source is actually not shared with other mesh current, then you can say like that.
Yeah, Doctor, I got
Okay.
confused.
Okay, and then 50, so this one is 100 IT if not mistaken. So please check. So negative 50 I1, so negative 50 I2. So this one 200
Yeah, Doctor,
I3.
200. Yeah.
And this one is negative 50. So this one is your second equations. Okay, so we have two variables, I1, I2, and I3, but currently we only have two equations. So the third equations come from this current source. As you can see right now, the current source is actually going up, which is in the same direction with I1. So I can write down my equation, I1 minus I2 plus 0 I3 is equals to 4 amperes, okay, or 4 only. So this is your third equation. So right now we have three variables and three equations. So by using your calculator, so you need to click mode equation and choose three unknowns. So your A1 should be 50. Just enter all the values. So negative 100, negative 400, sorry. Why my number is not going? Okay. My A2 is negative 50, negative 50, 200, negative 50, and the third equation is 1 minus 1 and 0 is equal to 4. So I will get my answer directly. X is actually your first variable, which is I1, 0.5, and I2 is negative 3.5, and my I3 is negative 1.
Doctor,
Yeah.
the answer not same with clockwise direction.
Yeah. Is it correct?
No, Doctor, it will be opposite sign.
Opposite sign.
Yeah,
Okay.
only.
So, okay, for I1, what is the value when you use clockwise?
Negative 0.5. All
Okay.
opposite
All
value.
opposite. Is it?
Yeah.
Is it? So actually the value is the same.
Yes.
Value is the same, but the sign is wrong. It's actually opposite. All.
Yes, because
Is it?
direction is different. It depends on the
Yeah,
direction.
yeah,
Yeah.
yeah. Okay. Tadi siapa yang cakap because I cannot see tadi tu. Chong
Uh,
Chong.
yeah, but
Aha.
doctor, my answer not same with Hussein. I don't know
Okay.
why.
Okay, what is your answer? I1 is
My I1 is 6.17
oh, okay. I2.
and then I2
Okay,
is
okay.
2.1
I1 is 6.57. I2 is
117.
6.17.
Yeah, yeah.
I1, okay.
I2 is
I2,
2.17,
okay. I3,
2.33.
okay. Okay, let's check because I have already done the calculation and then verified using LT Spice. This one is not. Let's see. Is it? Oh no. Mesh current example. Is it mesh current example 2? Okay, this one. So this one I actually did it, done it using clockwise. So my answer is like this. 0.5. Okay, you have the same magnitude but different opposite sign. This is when we use clockwise. As you can see here, this is clockwise. So maybe your I don't know, maybe something that you miscalculate or you misenter the value inside the calculator. So as you can see, this one I got the same, okay, the same values, but only the sign is actually opposite. Okay, Chong?
Okay, I will check back.
Okay, you
Thank you,
can double
doctor.
check. Okay, so to highlight what Hussein has raised, the issue is actually on the sign. Okay, yeah, okay, the sign. So actually, the answer is correct, and the sign, as you can see, is actually 0.5, meaning that the direction of the mesh current that you assume at the first place during during the definition of the current direction. So meaning that I1 is actually flowing in this direction. It's going in this direction. So your current I1 mesh current is actually for this one is the branch current. Okay, branch current for 400 volt. So the current is flowing into the positive terminal of the batteries. Okay, while for I2, meaning that negative 3.5, meaning that the direction of the current that you assume is actually in reverse direction. So the correct current direction should be in this direction. Okay. And also for the I3. So for the I3 is actually -1, meaning that the direction here is actually reverse. So the current should flow, we actually should flow like this, okay, in opposite direction. Okay. So, but it's okay. You don't need to panic, okay, because you just stick with the values that you have already choose. Okay. For example, um, you are using this anti-clockwise and then you obtain these values. Then this is correct. Do not panic. Do not what you call change the sign of the current and so on. Just leave it like that because we haven't finished yet. Okay, because the question is right now is to obtain IO. Okay, so to obtain IO. So based on this direction IO, you need, okay, IO. So right now IO is in the same direction with I2, but IO also is, as you can see, this branch current IO is actually shared with there are two currents, I2 and I3. But since IO is in the same direction of I2, so you need to write down the equation I2 minus I3. Okay? The same that we have already implement to obtain the 4 amperes here. Okay, 4 amperes is actually in the direction of I1, so that's why I need to write down I1 minus I2 is equal to 4. Okay, the same applies for IO here. So IO, so as you can see, the direction is the same with I2. So we need to write down the equation like this. I2 minus I3. Then what is your I2? So your I2 is negative 3.5. Okay, and your I3 is negative 1. So this one should be negative 3.5 plus 1 should be negative 2.5.
Doctor,
Yes.
if I use clockwise, I take the super mesh as the reference to compare with I naught IO. And then I write IO equal to negative bracket IB minus IC. Can I do like that? Because it is opposite to the super mesh clockwise mesh current.
Can you repeat?
Like I do the circuit in clockwise. Yeah.
Meaning like this. Okay. Let me show my. Okay, this one like this. Can you see?
Yes.
Okay. And then your super mesh.
Super mesh is anti-clockwise.
Oh, anti-clockwise.
Opposite. No. Super mesh is opposite to the current IO.
So meaning that your mesh current I1 and I2 clockwise, and then you create a super mesh, right?
Also clockwise.
Clockwise, okay. Clockwise, okay. Okay. Then.
And then I use the super mesh as to calculate the I naught, and the super mesh current direction is opposite to the I naught.
Oh, I see. Yes. You can do that, but it will be confusing because right now you are dealing with I naught, right? Because right now, what you are dealing right now is I1. You have variables I1, I2, and I3, and then you create another one which is I naught. I naught is I2 minus I. To answer your question, yes, it's possible, but it will be, I think, will be very, very complicated because it involves a lot of variables.
So I should take the since this is clockwise and I3 is same as I naught, so I take I3 minus I2 like that.
Yes.
Okay. Thank you, doctor.
Yes. For example, if you are using clockwise, the same thing. Okay, what you need to do is to have the super mesh. This is the super mesh from the super mesh. Okay. And this one is actually comes from your mesh current I3. Okay, this one, mesh current I3. So you have negative 50I, negative 50I2 plus 200I3 is equal to 50. And then the third equations come from the current source, which is right now based on clockwise. So I2 minus I1. Okay, I2 minus I1 is equal to 4. Then after that, I will obtain like this. But as you can see, the values is the same, but the direction of the current is actually opposite because we assume clockwise. Okay. Then to obtain the answer for IO, so you need to, for clockwise, so you need to look at the direction of the current. So since you are using clockwise, okay, so please be consistent, do not change. So IO based on the assumption that you made, okay, do not change, okay. If you are using clockwise, state just what you call static at that, consistent, do not change. Okay, so based on IO right now and your mesh current direction that you assume, so IO is in the same direction, which is equals to I3 minus I2, right? So I3 minus I2. Same, you will obtain that IO is negative 2.5. If I use the anti-clockwise also, I will obtain my IO is also negative 2.5. So as mentioned before, it doesn't matter is it what I should start. Is it I should start with mesh current opposite or counterclockwise or clockwise? It doesn't matter. Okay? So your answer will be, the final answer will be the same. Okay? Your mesh current may be not the same because of the opposite sign. But actually, because this mesh current sign is depends on the direction of the mesh current that you assume. Okay? But the final answer, for example, to get the IO or maybe to get the voltage across 50 ohm is actually all will be the same. You will get the same answer even though you are using counterclockwise or clockwise during the mesh analysis. Okay. So your final answer IO is negative 2.5, meaning that, yeah, 2.5. Just leave it like that, 2.5. I don't want to elaborate. Okay, so any question before we proceed with the next question? Okay, I have already done this. I will post it after this, my Word file. Okay, so I need to clear this one. I don't know. This is whiteboard. Microsoft Whiteboard is actually has been upgraded, but I think it looks like a downgrade version because I cannot delete or cannot. Actually, the previous version is much better compared to this because for the previous version, I can just clear the canvas, okay, without erasing. But right now, I need to erase one by one. Okay, so let's look on okay, on the second circuit. This one, okay. Determine V1 and V2 in the circuit, okay, using the mesh analysis. So as you can see, we don't have current source, so meaning that we don't have mesh current super mesh. Okay, so just clockwise. So I1, I2, I don't know, maybe this one I2 got I2. Just assume, okay? Just assume. For me, I prefer to use clockwise. I don't know why. It's based on your prefer which one that you prefer. Okay, so I1 from here, I can see that I can write down this one is equals to, I start from here, okay? 10 ohms here. So 10 ohms, and then as you can see, we have two mesh current going into. So since we are concentrating on the first mesh current, so you need to write down KVL for mesh current, okay? So during the test, it's good to have this. You need to write, okay, so that we can trace, okay? So I don't know for this semesters how we conduct the marking. Usually for the final exam marking, only one lecturer will actually mark one questions for all sections. Okay, so we have, I think, 12 sections. So one lecturer will actually marking for the whole sections. Okay, so um, so you need to be very what you call very good lah, not very good lah orang kata apa. Must be your methods tu, your calculation method need to be very very clear, because sometimes the lecturers, yeah, you can imagine 12 sections, so around maybe 600 students papers he need to mark, so it's quite challenging. Okay, so if you present your method of calculation in a very clean sheet and so on, so it will actually give some motivation to the examiner lah untuk correct your punya answer, correct dia punya answer tu kan. Okay. So 10 this one is I1 minus I3. Okay, because we assume that, yeah, why I write down like this, because we assume that the current direction is going like this, entering the positive terminal. Okay, that's why. So meaning that I1 is larger than I3. Okay, that's why. Okay, and then 20 I1 plus 10. So the current is entering this terminal also. So meaning that I1 is bigger than I2. And then plus 100. Go to 0. So this one, okay, can we double check? So this one will become 40. I1. This one is negative 10 I2. And this one negative 10 I3. So this one will become negative 100. Okay. And then KVL for mesh current I2. Okay. So mesh current I2, we start with this one. So the positive terminal like this. So meaning that the current is entering, the I2 is much bigger. So 10 I2 minus I3. And then negative 100 plus 10 I2 minus I3 plus 10 I2, so equal to 0. So this one 30 I2. Okay, 30 I2.
Doctor,
Negative
I think one of the 10, it should be I2 minus I1.
Which one?
We
Mesh
have
current I1 or I2?
for I2 we have two of 10 I2 minus I3. I think one of them should be I2 minus I1.
I2 minus I1. Oh, okay. I2 minus I1. Yes. Yes, I2 minus I1. Okay. Thank you. Okay, I2 minus I1. So this one. So this one should be negative 10 I1 plus 20 I2. Sorry, 30. Okay, 1, 2, 3, and then negative 10 I3. So this one is 0. So this one is 100. So this is your second equations. And the third equations is so just ignore the polarity, okay? Just ignore this one, because this V2 and V1 is your questions. We will go after that. So just assume that I3, so the polarity is like this. Okay, 20 I3, and then 10 I3 minus I1, and then this one polarity is like this. Okay, so 10 I3 minus I2 equal to 0. Okay. Okay, and then we rearrange this one. I will obtain negative 10 I1, negative 10 I2, and then 1, 2, 3, 4. 40 I3 equal to 0. So this is my third equations. Okay, so this one KVL mesh I3. Okay. If you highlight this, maybe the examiner will be very happy, okay, because it can trace very easy. Because not everybody will do clockwise. Okay, not every student will do clockwise. So some student may do counterclockwise and so on. So you can imagine how the examiner need to check and double check again and again. Okay. So we have 3 variables. So the first one we just enter the values. Hey, this one. I think reset lah. 3. Okay, I1. Okay, the first. This one negative 10. If 10. This one is 30. Negative 10 equals to 100. Negative 10. Negative 10. 40. And the answer is 0. So you will obtain my I1 is negative 1.79. My I2 is 2.8. My mesh current I3 is 0.256. Okay, so this is the answer when for the mesh current. So right now we go for to answer the question. So what is your V1 and V2? Okay, so we go for V1 first. So the current direction mesh current is like this. Okay, so for V1, so V1 IR. Okay, so right now your current is I2. And the mesh current that we assume is actually entering the positive terminal. So positive. So positive, and then the value is 2.8. Multiply with the values of the resistor. So it will become positive 28 volt. Okay. And what about V2? So your V2, right now, the I3 is entering the negative terminal. So negative IR. Okay. So negative, the current is positive values. So 0.256 multiply with the values of the resistor. So you will obtain this one is equals to 20 multiply with 0.256. 5.12 volt. Okay, so that's why I said you need to be consistent. If you assume clockwise, so please stick to the clockwise direction. Okay, and then to obtain the voltage, so assume that the current is based on your assumption, the current is actually entering the positive terminal, so you have positive. Okay, and for example like this, you current I3 is entering the negative terminal, so you will obtain like this lah. Okay, understood. For example, if you have like this, for example, your I3 is negative. Okay, your I3 is negative 0.256 based on the calculation. Okay, example, just an example. Okay, so just stick to the current here, I3 direction. The I3 direction is entering negative terminal. So what you need to do is actually just follow. So entering negative terminal, so your V is negative. Negative, and the value of the I3 is negative 0.256 multiplied with 10. So you will have positive 5.2. Simple like that. Okay. So don't change the sign or so on. So if you obtain the sign positive, so just stick to the positive. Okay. That's why for the first answer too, I don't want to elaborate because it will make student will be more confusing. Okay. For example, this mesh current, you obtain these values. Okay. I1, I2, and I3, and then the question want you to get V2. So V2, the current I3 that you assume is actually entering negative terminal. So just put negative here. You will obtain the value is negative 5.12. Okay, maybe for this one, V3, for example, the polarity is set like this, positive and negative. So V3, as you can see, is actually the current I1 is entering the positive terminal. So your I1 is negative 1.79 multiplied with 20 ohm. So you will obtain negative berapa So why? Oh, hang Okay, 20 plus multiply 1.79 negative. So you will obtain negative 35.8. Okay, so just leave it like that. So this is your answer. Just to double check with my answer, example, this one example berapa is it correct? Yes. Oh, no. 28.5, this one 5.7. Betul lah. Negative 1.72. Oh, that is slightly changed lah. That is slightly different. Okay. So I need to double check this one. But because the answer is slightly different, 25.8 and 5.7. This one is 25.8. 28. This one 5.12. So because the mesh current is different. So mesh current I1 is negative K 1.79, 2.85. Oh, because I ignore the second values here, 2.85. So I just take 2.8 only. Okay. But it doesn't matter because I always usually look at how the student solve. Okay, if the value is actually quite similar, then I accept the answer. Okay. Any question regarding this? I hope this one is straightforward. Okay, it's very straightforward.
Doctor,
Yes.
for voltage 2Y is 5.12.
Voltage to
Uh,
5.12. Okay, negative 5.12.
it should
This
like
one 20. This one 20.
Oh, okay.
20. Sorry, 20, not 10. Okay. The third questions that we want to discuss will be much not complicated. It's actually just a straightforward, but the final question is quite confusing. Okay, do you have any question on this before we move to the last questions? I don't know how to clear this all. I think maybe we just put this one and then maybe delete. No. Is it? Okay, much better. Okay, and then this one, I go for the last one. Is it this one? Oh no. Because I just download from, no. Okay. Looks easy, but the last question, which is actually the question, find VO, which is the voltage drop across 10 ohm here plus voltage drop across 10 ohm here. So it will be confusing. Okay. So mesh analysis. So I assume that this one just to create some what I call trigger you something, okay? Trigger you on the idea of mesh analysis. Okay, so this is my I1 and this one is I2 and this one I3. Okay, so Hussein, so right now, as you can see, I3, you have a current source here, and this current source is not shared with other mesh current. So you can just put I3 is equals to the mesh current. But right now, my current direction is in opposite of the mesh current of the current source. So I need to put negative 10. Okay. So only two mesh current are required to be derive the equation. Okay.
Okay.
Okay. So mesh, oh sorry, KVL. Just put, you can put right like this from mesh I3. So you can just put I3 is equal to, okay. And then KVL for mesh I1. So this one is 10. This one, only one current kan. 10 I1 negative 400. Oh, we have Filipino here, right? If not mistaken. Do we
Yes,
have?
doctor.
Yeah. Maria, is it? Maria.
Yes, yes.
Okay. Where are you from? You're from Manila or what?
Yes, I'm from Manila, doctor.
So right now you are still in Manila.
Yes.
Okay. So only you are Filipino, or you have another friends that inside this?
I only
No.
know a senior from
Okay.
civil engineering that's
Oh,
Filipino. Other than
civil
that, I don't know any.
engineering. Oh, civil engineering. I
Yeah.
thought that this is only for biomedical students.
I only know one other Filipino student.
Okay. Other students come from this medical student, right? Medical bio, right?
Yeah.
Okay. Majority, I think majority of them, because this is SEEU. I don't know for the civil engineering whether the code is similar or not. I think for the civil, I think the code should be have a capital A. Okay. Wait. Okay. Okay. So we continue. So negative 400 volts, and then plus 10 I1 minus I2. Okay, because the polarity should be like this. Okay, so I1 minus I2. Oops. So equal to 0. So this one will be 20 I1 minus 10 I2 equals to 400. Okay. So maybe I can put this as a positive 0 I3 equal to 400. The same case also goes to here. So 0 I1 plus 0 I2 plus I3 is equal to negative 10. So this is my first equation. This is my second equation. Okay, so 3 variables. So we need another equation. Okay, so right now we have two equations. So KVL for mesh 2. Okay, so this one is negative 100 plus the polarity like this. So 10 I2 minus I1. I2 minus I3. Okay, I2 minus I3. And then polarity also like this. So this one plus 10 I2 minus I1 equal to 0. Okay, so this one should be negative 10 I1 and then plus 20 I2 minus 10 I3 is equal to 100. So this is my third equations. So I have three equations, three variables, so you can use your calculator. So no need for the test and so on, no need to do it manually, just use the tools of calculator, then it's still acceptable. Okay, 0, because during your work as an engineer, you don't need to, if there is a shortcut, okay, assistant, then just use it. Negative 10, and then for A2 is actually 20, negative 10. You are lucky, you know, because during my time, I need to show all the calculations manually. So during your times, it's much easier. Oh, sorry, this one. Oh, A3. Oh, I think I need to A1 0. Okay, 1. A2 20, negative 10. Oh, this one should be 0. D is actually 400. And then A3 is negative 10, 20, negative 10, and 100. Okay, so this is circuit. So if for simultaneous equation, it can be done manually, very straightforward. But somehow it's also sometimes it's quite complicated. You imagine that for AC circuit, okay, after the semester break, you will be introduced with the AC circuit, where inside the AC circuit you have inductor and capacitors. So inductor and capacitor, it has what you call imaginary numbers, okay, J or I sometimes in the calculator. So you can imagine that you have three simultaneous equations with complex numbers. So it's quite time consuming at that time. So your I1 is 26.7. I2 is 13.33. And I3 is negative. Okay, I3 is already calculated 10. Okay. Okay, so we have complete the mesh analysis. Now the main question is to find your VO. Okay. Okay, so how to find your VO? So I
Noted.
assume that, sorry. Okay. Okay. Do you want to ask, Hussein?
No, nothing, Doctor.
Okay. Okay, so VO is actually from here to here. Okay, that is when you tap your voltmeter, the reading. So this is your voltmeter. Okay, tap positive and negative here. So what is the reading from your voltmeter? So I assume that the polarity of the voltage drop of 10 is like this. Same also. Okay, so meaning that your VO is the summation of the voltage drop across these two resistors. Okay, so your VO is actually V10 plus V10. So right now, what is the what is the voltage across this one? Okay, so V10, the first one, I think this one A. Okay, I define as a V10A, and this one is V10B. Okay, so V10A is actually IR. So right now, what is your current? What is your current that flow inside this 10 ohm? Okay, based on the mesh analysis that we have already done. So you have two mesh current, right? Clockwise, which is I1, and the second one is I2. Okay, so right now, the polarity is like this, positive here. So meaning that I1 is larger than I2. So I need to write down my equation, I1 minus I2. Okay, so meaning this is the branch current. I1 minus I2 is the branch current that flows into 10 ohm. So, and then multiply with 10 ohm. So, and then you substitute the values of I1, 26.7 minus 13.3 multiply with 10. So this one calculator mode is set to COM. So 26.7 minus 13.3. So multiply with 10. So this one should be 134 volts. Positive 134 volts. Okay. What about V10B? V10B, okay. So the polarity is like this. But the current of the mesh current is flowing like this, right? So it's actually entering the negative terminal. Okay. So V10B is negative IR. Okay, negative IR. So negative, and your current is I3. So the value of I3 is negative 10. Multiply with the resistor values 10. So this one is actually 100. So your VO is 134 plus 100, which is 234 volts. Okay, so the answer here has been verified. I have verified using LT Spice. So the answer is correct, which is 234.
Doctor,
Yes.
but for this circuit, I don't know I got calculated wrong or not, because I just get the, if I use anti-clockwise, the loop 2 equation is same as clockwise with anti-clockwise. But for loop 1, the 400 is become negative 400. So like this, the answer will become different. But
Okay, what is the answer? Usually, as mentioned before, for the
yeah,
using you should get the same values, but the sign will be different. If you are using counterclockwise, I1 should be negative 26.7. But right now, what is your answer for I1?
I get different with this answer.
Okay, what is your answer? I1, for example, I1.
16.
Oh, 16.
I
I2?
is 8.
Huh?
8.
8. I3 is negative 10. 10.
Yeah.
10.
10, right? 10.
Okay. It maybe have some miscalculation, I think. Miscalculate somewhere. Because if you use counterclockwise, should have the same, at least should have the same. Okay, let's try to do it counterclockwise. We have much. I hope you understand this one. Okay, everybody, the VO. Okay.
Oh, never mind, doctor. Already get the answer.
Oh, why? Why the you maybe entering?
Because the calculator mode doesn't
Oh,
put the unknown 3 because I assume that I3 already got the answer, so I no put I3 inside.
Okay, okay, okay. So I3 is just put like this, right? 001.
Oh,
001 because 001 is equal to -10. Because you need to put the variables values I1 and I2. Okay. Okay, I hope everybody understand this one. Okay.
So can I ask a question?
Okay.
The positive minus polarity for the resistance when you put, is it assumption or
Yeah, it's actually assumption. Yes. For example, okay, let me for VO here, my assumption that the 10, this is the polarity. Okay. That is my assumption. Okay. What if my assumption is like this? This one negative, this one positive, this one negative, this one positive. Okay, let's try. Okay, so my VO is equals to negative V10A, negative V10B, right? So what is your V10A? Your V10A is negative. The current direction is actually, this is your I1 and this is your I2. Okay, so I1 minus I2. Sorry, I2 minus I1. Okay, because the current we always entering the positive terminal. Okay,
Doctor, why you put it, why you put negative V 10A and negative? Why not positive?
because how to say because when you put here voltmeter, and then you how to say we just assume that the polarity is like that. We just say like it's still just an example. I can usually what we do is actually we put this as a positive. So meaning that VO is actually the summation of voltage drop of 10A plus 10B, right? Because positive.
Okay, Doctor.
Okay. This one is assumption lah. Okay. But I just want to show you what happened when we assume the polarity is like this. Okay. So meaning that the summation, the VO is actually the summation of V10A and also V10B. Okay. So your V10A is what? Is actually I R. Okay. And then we have current. I1 also I2. So based on this current direction, okay, right now, are you confusing? Are you confused right now? Not yet.
No, sir, خلاص, never mind, no problem.
Okay, so your V10A right now is negative. V10A is negative. Okay, so your current right now is I1 minus I2. Okay, multiply with R. So you will obtain this one is negative. So 26.7 minus 13.3 multiply with 10. So you will obtain negative negative 133 volts. Okay, 133 volt. And for V10B is actually negative also. Okay, negative IR. So your current is actually, okay, so this is your I3, where I3 is negative 10. Okay. So this one is actually negative or negative. So we have 10 here, multiply with R, multiply with R, the R is actually 10 ohm. Okay, so you will have negative 100. So this one, negative 133. So you will have actually positive. Still you have positive 233 also. So it doesn't matter the polarity that you assume. You will have the same answer.
Doctor.
Okay, sorry, this one, sorry, this one is positive. Sorry, this one positive, this one negative. Okay, because the current is entering the positive terminal here. This one, the current is entering the negative terminal. Okay.
Sorry, doctor.
Yeah.
Can I assume that the quality at the upper side register, I mean the 10 ohm, is positive then negative?
Yes, possible. Meaning that you want to this one positive and then this one negative.
Yeah.
Yes, possible. Also can.
Okay, thank you, doctor.
But it will be very confusing lah. Okay, usually for me it's better to use what called conventional way because the voltage. So because this one is your reference, right? So I always use positive, negative, positive, negative. Please just standard. But you can, if you want to just for your own comprehension, okay, you can just put like this and so on. It's still okay. You will get the same answer actually. Okay. This one I need to double check. whether I'm correct or not. I will send this in the WhatsApp group, the solution for all the questions. This one I have recorded, so you can just watch it in my YouTube channel after this. Okay, so any questions? So if there is no question, then we can dismiss today class.
Doctor.
Okay, Maria?
Um, may I ask if there's any past tests that we can practice on for upcoming tests, or any tips that you can give for
Okay.
our revisions? Thank you.
Yeah, I will give it the previous test one for your exercise. But I don't know whether the answer scheme that I have in my possession is it correct or not, because sometimes we do need to revise the answer scheme. But I will give it to you, okay, after this. And then do you have already download this textbook, Alexander and Sadiku? Because I afraid that I forgot to mention about our books during our class. Have I already mentioned about this?
There, you take the exercises from the book.
Yes.
Okay.
Yeah. This is actually from the textbook from Alexander and Sadiku. So you can do some exercise on that. Okay. But the question from the book is quite tough. It's quite tough. Okay. And only questions that are in odd numbers. For example, 51, 53 have the answer at the back of the book. Have I don't know, because right now I'm actually teaching two courses that use the same textbook. So the first is this is the course SEEU 1023, and I also teach another course which is for the third year course, second year course 2423, that using the same books. So I afraid that I maybe forgot to mention about the textbook in your class, because yeah, two courses use the same book, so that's why sometimes I forgot. So sometimes I also confused. Sometimes I post the exercise at wrong group. So if not, then I think I will post it in the WhatsApp group for you to download. Okay, I have the soft copy for this book for you to do some exercise. Yes, you need you need to have exercise to familiarize the circuit and so on.
Thank you, doctor.
Okay.
Thank you.
So
Doctor,
yeah.
I think you have posted the textbook in the e-learning.
Maybe I will post it. Okay, this is this is the textbook. I have the soft copy. So maybe for your convenience, I will post it in the group lah. Okay, but just to clear, just to make yourself also clear, because this is the service, okay, service cost. So the level of electrical engineering and the biomedical engineering syllabus is quite different. So for example, you can see in electrical engineering, we introduce the student what you call the dependent source, meaning that the voltage here is the value of the voltage source here is dependent on the voltage drop across 3 ohms here, Vx. So this is what we call dependent source. Okay, but for your course, we didn't introduce you this dependent source. We only concentrate on the independent source. Okay, so some of the examples and solution, they included the dependent source, so you need to exclude them. Okay, don't do that. Just choose the what you call the question that is related to our syllabus. Okay. Okay, actually all the exercise here is you can try, you need to exclude the exercise that have the dependent source only. Okay, for example, this circuit, you have a dependent source, so you cannot do this. Okay, because this is out of your syllabus. Okay, so just to make yourself clear also, so we have a DC circuit, so you can try chapter 2 and also chapter 3. Okay, chapter 2 and chapter 3. So chapter 3 is the method of analysis where we have the nodal and also mesh current. Okay, mesh analysis. Okay, so next on our next class, which is next week, we concentrate on what we call the circuit theorem. So the circuit theorem here, we will introduce you about the superposition, source transformation, Thevenin, and also Norton theorem. So this is the last circuit theorems, okay, for the DC circuit. So I think week 9 or week 8 we will go to the AC circuit. Okay, so we will introduce you on the analysis of the AC circuit. Actually, the method of analysis, the basic laws is actually the same one we can apply for the AC circuit. But as I mentioned earlier, AC circuit involve complex numbers. So the calculation will be very, very complicated and so on. Okay. Okay, so I think that's all.
Doctor,
Okay. Yes.
for the nodal analysis, they have many ways to let us to find out the nodal voltage, right? Then
Yes.
for us, we need to learn how to use camera rules and MATLAB or not.
Oh, okay. No need, no need. Just use calculator.
Oh, okay. Thank you, doctor.
That's actually the Kramer rules is actually the method that we need to show during my study in university. We need to show how we do the calculation, the simultaneous equation using Kramer method. Okay, but for this present time, is actually we ignore that. We just use calculator. So we encourage students to use calculator. Just use the calculator. Okay, the first thing what you need to do is actually to come out with, you just need to show us your simultaneous equations. Equation 1, equation 2. Okay, and or maybe equation 3. And then just write down the answer based on calculator. So I1 is this, I2 is this, and I3 is this. Okay, so no need. For the assignment also, maybe by today or tomorrow, I will post the assignment. That one is the individual assignment. You need one. I think I will give you 1 or 2 questions only. I think 2 questions lah. 2 questions. So do it manually. Do calculations. For example, if they required simultaneous equation, just show the equations and the answer only. Don't need to use the Kramer rules and so on. Okay, that for the manual calculation. And you need to verify your answer by doing the simulation using LT Spice. Okay, so using LT Spice, you just snapshot. Okay, for example, like this. Okay, I show you. Okay. For example, this is the circuit. So just show me the node voltage. Okay, because from here you cannot calculate, you cannot show the current, right? For example, the current flow through R3. So just show the node voltage. Okay. And please don't copy your friends. Okay, please do it yourself. Okay, because it didn't what you call help you lah. You need to do it because this is the simulation is very simple. So I hope you can have some experience, explore the using of
Doctor,
the software and so on. Okay.
so Doctor, the two questions that you'll give us, we should, this is for the assignment?
Yes, yes, assignment.
Okay.
I will post it for you. Maybe for your exercise, for your own exercise to prepare for the first test. So I will give you the previous test one for you to prepare for your incoming first test. Okay, that is for your own exercise. And then I will also post it to you assignment questions. Okay, 2 assignment questions that you need to do manually and then do calculation manually and then prove it by
Doctor,
using
sorry,
this
your
class.
voice is a little bit lagging. If you can write the instruction in the WhatsApp.
Okay, I will,
Yeah.
no worry, I will give the instruction in the WhatsApp group.
Okay, Doctor, thank you.
Okay, so I think that's all. I didn't check the chat room. Oh, okay. Sorry for that. I hope I have already answered this question from Yen Lo. Okay. So that's all from me. Thank you very much for your cooperation throughout this class. So 1 hour and plus. Okay, thank you very much. Okay, Assalamualaikum and have a very good day.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Okay.
Doctor.
See you later.
Thank you, Doctor.
Thank you.